All right, let's talk about part 3, which is chapters 7 to 11. And this part he calls design principles, which would get you really excited, except that he doesn't talk about design at all. He talks about the solid principles. He does a really good job of diving into each of the solid principles. There's literally just one per chapter, so he really dives in. That's the good part. The bad part is that the solid principles does not a good app make. Like, it's good to be aware of them, but you also need 10-factor apps, actual design thinking, and profit considerations. You don't just want a solid system that you've built without considering empirical data. Looking at the solid principles themselves, he calls out Conway's law. We love Conway's law. Go read up on Conway's law. He doesn't do a good job of explaining it here. And Conway's law is very different from the single responsibility principle. So an agile team will be doing more than one thing for sure, always. And I'm surprised to actually see him support the DIP, the principle of dependency inversion, because this contradicts earlier in chapter 1, his principle of co-equality of low-level and high-level considerations, because DIP it's like a hierarchical principle. It says that the low level needs to obey the high level, basically. So my take is that DIP is garbage and that the earlier take of co-equality is actually a better principle. I won't take you through all the chapters. We'll just jump to DIP. A lot of this stuff is not controversial, and I actually want to give him kudos for considering solid principles for system design. A lot of people think solid principles are principles of OOP specifically, but they're not. You can take a lot of those things like the Liskov substitution principle and apply them to functional systems as well. And even outside of the code at the system level, being able to swap out interfaces is a really great technique. So that's the good stuff. Now let's get to the bad stuff with DIP. Again, the DIP tells us that the most flexible system is blah, blah, blah. Who cares? Because the most flexible system is not the best system unless you're plugging your ears in and ignoring business considerations like profit, which you should never do. Refer only to abstractions, not concretions. This is like a bad idea. Beware of abstraction hell. He refers to Java. Yeah, Java is a great example of abstraction hell. Factories. Do you always need a factory? No. Do you always need an abstract factory? Absolutely not. He has a diagram. Cool, nice diagram. He says, hey, that diagram has a concrete component, so it violates DIP. My response is, I don't care. I don't care. Every implementation needs an abstract base class or superclass is a terrible take. That's me, that's not him. This was a pretty short section. Follow along for the next section.